Hi guys, this is our first video on chemistry, and we're starting off with organic chemistry. Um, yeah, okay, let's get straight into it. So organic chemistry is the study of compounds of one element only, namely carbon, right? So in organic chemistry, we are looking only on the carbon atom. Um, I understand I will say only, and then I'll start looking at, other halogens, maybe bromine or fluoride or stuff like that. Um, we are focusing really on carbon, but other atoms, non-metals, can sort of like come on board, things like hydrogen and stuff like that. But really, what we're looking at it's really the carbon atom, right? So they are in the region of 7 million carbon compounds, right? So we have a lot of carbon compounds. And really, what makes us have that much, it's, I mean, if you think about organic things or living things, from viruses, fungus, I don't know, bacterias, to all the way to plants, all the small plants like, I don't know, ferns and algae and stuff like that, to big trees, to us people, animals and stuff like that. We all made of this compound, right, which is the carbon compounds, right? So that's why we have so much carbon compounds, right? In fact, if you look at the reactions, that happens inside the body, whether it's DNA replication, or I don't know, they all use enzymes, and those enzymes themselves are made of carbon compounds, right? So I've sort of like made a list here of all these. So if you look at, they say the complex molecular structures that make up living cells and enzymes that controls the reactions within them are carbon compounds, hence the name organic chemistry, right? So almost all plastics, synthetic fibers such as polyester, nylon, natural fibers such as silk. If you look at cotton and wool, drugs, pesticides, crude oil, and all its derivatives, things like petrol, paraffin, and diesel, they are all organic compounds. They are really all organic compounds. Yeah, so I mean, and they are mainly made of carbon, right? So if you look at petrol, for instance, if you look at petrol, paraffin, and diesel, and you also look at some, if you look at wood and stuff like that, when you burn them, they produce carbon monoxide and carbon dioxide. Basically, the oxygen that is there is just coming the atmosphere, but the carbon itself is coming from the petrol itself, the paraffin itself, the diesel itself, the wood itself, right? Yeah, so I once had a conversation with a friend of mine and our mentor, and she was basically asking, where, and she's a chemical engineer, so I really think that question was more than that, more than what we answered. I think she wanted to know more than we just sort of like answered. So she was asking, where is the bulk of a tree coming from? You start with a small seed, and suddenly, when the tree is very old and whatever, you sort of like have this big tree. And she was basically saying, where does the material in that tree comes from? And we all just said carbon. We all just said carbon. It's true, right? It's true. So now, how are we going to study, a study that involves about 7 million carbon, so 7 million compounds, right? In this case, 7 million carbon compounds, to be specific, right? How are we going to sort of like study such variety? So fortunately, in this case, what we have is that these 7 million carbon compounds are sort of like divided into special groups, right? they are divided into special groups, and basically it is those groups that we'll be studying, right? So fortunately, the unique properties of carbon that make this diversity possible also result in compounds that fall into a distinct group called homologous series. We will study some of these groups and their physical and chemical properties, right? That's really what we're gonna be looking at. So what you see here is sort of like a picture of a cotton, and what you see over here is the sort of like a molecular structure of that, right? Yeah. So let's look deep into what do we mean by this homologous series. So a homologous series is a series of organic compounds that can be described by the same general formula, right? You will soon understand what we mean by that, or in which one member differs from the next with a CH2 group, right? Guys, I'm not sure how consistent I am. I made definitions purple. So not only definitions though, things that I thought were important, I made them purple. So please take notes as much as possible, right? And also I'll start repeating stuff that I think is important, right? Okay, so now let's really look at this carbon atom, right? So it has 4 valence electrons, right? So what does that mean? It means, so this is actually a structure. It's called the tetrahedral structure, right? This is a structure of a carbon, and it has 4 valence electrons, and that means basically it can bond to 4 other sort of like bonds, right? It is unique in its ability to form covalent bonds both with other carbon atoms and with atoms of other nonmetals. So really it can bond with other carbon. So this over here could be another carbon, right? And also it can bond with other nonmetals. Like for instance over here, this can really be a hydrogen. I think it can only be a hydrogen. No, that's not correct. So this, in this case, it's a hydrogen, right? But obviously you can have other things here. So the bonds that it makes with another carbon can either be single or triple, or so you're gonna see later on, but I'm just focusing on what's here. The covalent bonds formed with other carbon atoms are either single, double, or triple, right? This ability leads to the formation of long chains called catenation. That's really a very, very important definition over there, right? Or maybe it's something that I would recommend you looking up, right? It would be great if you can look up what do we mean by catenation. So this can give us long chains. This thing of having single, double, and triple sort of like bonds can give us long chains, and it can also give us ring structures. The bond between carbon and hydrogen is also strong, right? So it's a very strong bond. It's referred to as a hydrogen bond. We're going to be looking at all those things. It's a very, very, very strong bond, and almost all organic molecules contain at least a 1C carbon to hydrogen bond, right? When organic compounds contain only carbon and hydrogen, right? If you have a carbon compound that has only carbon and hydrogen, we refer to them as hydrocarbons, right? That's also a very important definition there. I mean, a different, very important term that you could look up, Compounds in which the carbon atom only have single bond, they contain the maximum number of hydrogens, right? So if you will see that, you can note it for a moment. Guys, I'm really gonna stop this video right here, but I'll make another video quickly to sort of like finish what we are looking at, right? We're still looking at the amazing carbon atom. So I'll stop the video right here, and I'll see you guys in the next video.